Hi everyone, this is our third video for the topic of surface area, and in this video we're going to look at the surface area of pyramids. So far we've done a review of area, including triangles and quadrilaterals, circles and sectors, and then last lesson we learnt about the surface area of rectangular and triangular prisms. So let's move on to pyramids. Now in a pyramid, except for the base shape, the other faces are all triangular. We can see that here. This is a rectangular pyramid. It's named for its base shape. And all of the other faces, there are 4 of them, are triangles. The cross-sectional shapes are not uniform. You can see that they're not the same size, but they are similar. So they're the same shape and they get smaller and smaller as they go towards the top here. The pyramid, if it's sitting on its base shape, then all the triangular faces will meet at a point, which is this point here, which is called the apex. Now there can be 2 different heights given with measurement questions with pyramids. So the first one is the perpendicular height, and it's the height that's perpendicular to the base shape. So you can see here, this height here is at right angles to the base shape. And then there's the slant height. And the slant height is the height of one of the triangular faces on the pyramid. And this particular pyramid is going to have 2 different slant heights. There's this one here for this face and for this face over here. And then there's this slant height as well. And that'll be the same length for the front triangle and the back one. So if we want to find the surface area of a pyramid, then we need to find the area of the faces. This particular pyramid has 5 faces. It has a bottom rectangle, the front and back triangles, which are the same size, and the 2 side triangles, which are the same size. So we could draw the net. It doesn't have to be to scale, but rather it's a rough sketch that will help us calculate the surface area. So we said 5 faces. There's a rectangle surrounded by 4 triangles. These 2 triangles are the same, and these 2 triangles are the same. And we know the rectangle has got dimensions 6 centimeters by 3 centimeters, so we can put that in. But the trouble is this 4 centimeter height here doesn't appear on our net, and we really need these slant heights. So let's return to this and we'll work out the area of the bottom rectangle because it's nice and easy. It'll just be 6 by 3, which is 18 centimeters squared. Now with the 2 side triangles, we need to calculate the slant height, and we're going to use Pythagoras' theorem to do that. So you can see how I've drawn up a right angled triangle in here. Here's our slant height. It's labelled x, and this distance along here is half of this side length, so it's 3 centimeters. Now we know this triangle. It's a 3, 4, 5 triangle. So you can write down x as being equal to 5 straight out if you want to, or you can do the full working. So x squared is 3 squared plus 4 squared, which is 25. X is equal to 5. And so once we know that that slant height is 5, we can work out the area of these 2 triangles. So this triangle here is going to have an area of a half times 3 times 5, and we want to double it. And working that out, we get 15 centimeters squared. And we need to do it again. So we need to work out the slant height of the front triangle. So I've drawn up the right angled triangle. This length along here is half of 3, which is 1.5, and I've labelled the hypotenuse y, and that height there is 4. So y squared is equal to 1.5 squared plus 4 squared, which is 18.25. Square root, y is equal to 4.27. And there it is. So now looking at the front triangle, the area will be a half times 6 times 4.27, and we've got 2 of those triangles. So there's the calculation, and into the calculator we get 25.62 centimeters squared. And our total surface area, we just got to add up the bottom rectangle, the 2 side triangles, and the front and back triangles, and we're going to get 58.6 centimeters squared. Here's another example. A triangular pyramid with equilateral sides is called a tetrahedron. It's one of the 5 platonic solids, and they're a special group of solids where all the faces are identical. The cube is another example of a platonic solid. Now, how many faces does this shape have? It's easy to look at it and think that there's only 3, but there's actually one on the bottom as well, so there's 4. If the edge length is 4 centimeters, calculate the total surface area in exact form. So because we've got 4 triangles that are all identical, we just need to work out the area of one of them and then multiply it by 4. So let's have a look at this front face here. We're going to need this height here. So I'm going to draw up a right angled triangle. We know the edge length is 4. We don't know this height here. This edge is 4 as well, but it's going to, that perpendicular there is going to cut it in half, so this is going to be 2. And we'll just put h there for the height. Let's use Pythagoras' theorem. H squared is 4 squared, take 2 squared, which is 12. And so h is the square root of 12. But because we want the total surface area in exact form, let's reduce that down. 12 is 4 times 3. Bringing the 4 out of the square root, we get 2 root 3. So now all we have to do is calculate the area of one of the sides and then multiply it by 4. So the area of the triangle is going to be a half times 4, which is the base, times the slant height, which is 2 root 3, and we have 4 triangles. And working that all out, we get 16 root 3 centimeters squared. So here's a practical problem. The Great Pyramid of Giza is a square-based pyramid. The square base has sides of length 230 meters. The perpendicular height is 147 meters. Find the surface area of the triangular sides. So the surface is composed of 4 identical triangles. That's because it's a square base. So once we know the area of one of the triangles, we just have to multiply that by 4 and we'll get the surface area. But we're going to need the slant height. So let's see if we can figure that out. I'm just going to draw up a right angled triangle here. So there's our slant height. And we've got a height of 147, and this length along here is going to be half of 230, which is 115. Okay, let's work it out. So s squared is 115 squared plus 147 squared, which is 34,834. Doing the square root, s is equal to 187 meters. So our surface area is going to be equal to 4 lots of a half times 230 times 187. And putting that in the calculator, we get 86,020 meters squared. Okay, so that's the end of this lesson. In our next lesson, we're going to look at the surface area of circular solids.